Hi everybody, it's time to talk about XinaBox power. So welcome to XinaBox Daily. We're gonna go through the power xChips, and they're very easy to recognize because they are all the ones that start with a P. So they're not the only one that provides power. I'm gonna talk about mainly the ones that provide that meant for power, and I'm also going to talk a little bit about those ones which have ability to provide power as well. So let's get going. I want to talk about a little bit about the background first. So one of the big problem in electronics is that very many circuit power standards as 1.8 volt, 3.3, 5 volt. In old days, we used 12 volt also. And the tendency is that we're gonna use less and less power and voltage level. So we have determined that 3.3 volts is the one that's most used, so most components on a PCB. So if I take, for example, a Raspberry Pi that I have here in my hand, then all the components here are talking to each other using 3.3 volts. So the different components, like if they have like a sensor or something like that, then a power supply is in most cases can deal with any kind of power from 1.8 volt to 5 volts, but if it's more narrow, then it's typically around 3.3 volts that can accept. Then we have too many power supply standards. So we have power supplies that can do anything from 1.5 volt up to power over Ethernet that do 48 volts. And we have all kind of different connectors. So finding like a power supply that is that's where there's one standard is almost impossible. And then of course there's too many wires. I mean, every time we have to power any of this thing here, there's nothing that just power it solidly. It's always via some kind of a wire. So I want to give an example of that. So here in my hand, I have a Dragon board, and this Dragon board here has a power supply that sits here. Okay, and if I get a little closer, I don't know if you can read it. Well, I don't know if you can read it, but it says here 6.5 to 18 volts there. Okay, and then it have like this power supply here. Now, what's interesting is that it does also have a USB, micro USB, but it can't be powered from that. I have to power it from this thing here. So this was a difficult one to get to work, because getting this powered, we have to find this very specific power supply. It didn't come with the board here. On the other hand, of course, we have like a Raspberry Pi. This is a Raspberry Pi 0, but there's no difference to the bigger Raspberry Pi. They have micro USB and they get powered by micro USB, and luckily they are easy to get hold of. Okay, so back to us. What did we decide to do? So we decided for a power standard of 3.3 volt. That means that our circuit inside the circuit run 3.3 volts. And if for some reason there's something on our circuit that doesn't run 3.3 volt, like for example, sometimes we have a component that maybe need 5 volt, maybe they need more, then we provide our little xChip. We provide a 3.3 volt, and our xChip itself have to figure out how it can make do with the 3.3 volt. It's not 100% like that, but that's the general idea here. The other standard we have is that we are providing power over our XBus. So if I take, for example, here is like a CW1. So this is a little Wi-Fi chip, some you can program. So it have a LED, And the way you power that is that you have to find another power source like this one here to power this circuit here. So we made sure that we have like a standard. But the whole idea is that we have a lot of different xChips that can then convert that standard to a standard we can use in our chip. So just some details. You don't have to memorize this thing here, but this just like when we talk about power, we have 10 pins on each our 4 sides of our xChips normally. So here I'm looking at what we call the west side of our xChip, and there's 5 on the top and a 5 on the bottom. And my blue arrows here is the ones on the top, and the red one is the one on the bottom or the back side of the xChip. So the middle one on the top here is ground, or minus if you kind of like think battery style. And 3.3 volt is the one on the other side of the notch. And that's like plus in battery language. And then we have 2 other pins here, and they're on top of each other, which also means that if you flip the xChips around, then it doesn't really matter because it's the 2 pins here that get mixed together. And they're not in big use at all. So the V-source pin is when you provide power to your circuit, then we allow that power. So for example, if you provide USB power, so you have like, in this case it's an IPO1, on the table here I have like a PO2 and PO1, they get USB power and USB provide 5 volts, then what we do is that we allow 5 volts to come into that pin. But just as a security measure, many times that 5 volt doesn't have to be used. So what we have is that if you want to use that 5 volt in your circuit, then you have to solder this little thing here that says V-source 5 volts. So as I mentioned, we hardly ever use it, but if you have to use it for like a special use, then you have to activate it here. The V-raw V-in is originally to put solar power in via the xChips. We are not doing that anymore, so we're not really using that pin at all. We don't have any xChips today that are drawing on that pin anymore. There is also another thing that's happening, and that is there is a standard. The European Union have passed what they call a vote. They still have to pass the law or get the law enforced, and that is that they will adopt one standard for charging all smartphones, and that's USB-C. So for that reason, we have started putting USB-C on some of our components, and of course the PO1 and PO2 here over time will also have a sister here called PO3, which have a USB-C on it. But some of our cores, like the CW3, have USB programming abilities, and we found that we might as well just put the USB straight on the CW3, so we both could power it and program it to kind of like lower the cost. So the CW3 is the first one. I'm going to demonstrate it later in this video here. So here's an overview. So we have USB power, and we have the PO1 and PO2 that you saw here on the table. And that's USB-A is the one that you normally plug in straight into your computer on the side of the computer. That's a connector or type that sits on a thumb drive or USB drive. And a micro USB, you know that from many Android-based phones and most other devices today powered over the micro USB. Then we have battery. We have a PBO1 and PBO4 that both take 2 AA batteries. The PBO4 is kind of like more advanced. It can tell you, what the voltage level is and what the current draw is. So you can use it to, measure when you expect the battery to go flat. The PBO1 doesn't have that functionality. And then we have PBO2, which is like a coin cell battery. I'm going to show that later on also. Then we have a generic power supply, and that's great for you have some power. You maybe have an old power supply you want to use, like you took one from an old laptop, or you have something else, you cut the wires, and you can simply just take those 2 poles and screw into a PTO1. Just have to be somewhere between 6 and 24 volts, and then you can use it to supply power. So for example, I have it in my garage door opener, where the garage door opener already have 12 volt there. So instead of trying to find power somewhere else, I just use the PTO1 and take the power from the garage door, and that way my circuit is powered. Then we have a group called LiPo. That's a rechargeable battery standard that's very popular, and that's the one we have chosen for rechargeable batteries. So we have a PLO1 and a PLO2, and a PLO1 supports the LiPo battery and charging using a micro USB, while the PLO2 you can also charge with a solar panel. There's other ways you can charge using solar on a PLO1, but the PLO2 has the charging circuit, so you just need to find yourself a solar panel and then screw it into the terminals on a PLO2. The current PLO2 you have out there, unfortunately, uses this bus pin that I mentioned that sits below the V source. Just hang on a second, Judy. So the PLO2 with the future PLO2 will have a screw terminal to actually be able to screw in any kind of solar panel. And then it's important also to talk about the bridges and interfaces, because the bridges and interfaces also provide powers to the circuit. So we don't want to kind of like have that you are building a circuit using, like say, a Raspberry Pi, and then you have to then find a separate power supply. So the power that comes from the single board computer where the bridge is being used, that power we will let through. And if that power is not 3.3 volt, we will convert it. So I'm going to demonstrate that also at the end of this video here. So let's look at the various use cases here. So the PO1 is the most prolific one. And it is that because today we can find chargers and charging facilities that provides power to a USB a lot. So I have a couple of different versions here. So first of all, there is of course the your normal power supply, and you can see we have a little blue LED that comes on here when I plug in the PO1. And then we have a PO2 here, and I have a little short cable on, and of course there's no big difference other than it's micro USB and we have a cable here. So that is one set of power solution. But let me quick run down. This is a UK power supply, and we can of course plug that straight in to this one here. This is a nice one. You can imagine you can click into the wall, and then you can have your circuit sitting there straight on the xChips, no wires, so therefore it's not dangling or anything like that. And of course there's no different from that to like a 2-pin similar adapter. The nice thing is of course that you can also find yourself a cigarette lighter adapter and do the same thing, and there are of course tons of them out there simply because all the smartphones are being charged with USB. The other thing that's nice is that you can get these small devices here that will tell you how much power you use. So in this one here, you can see that, I don't know if you can see, but it actually tells you here, sorry, I know it's like gonna be almost impossible, but it actually tells me here that 5.02 volt comes out of this thing here, and the current draw is so low, so you can see it actually switched off automatically because, yeah, there's nothing that runs on this. And then the last thing is that with this one here alone, you don't have to have like advanced solar panel device. If you have something that have solar panel that comes out here, then you can, just plug it in. So here's a solar panel. Just have to find it, and we are down. Sorry, find it here, and you can see here that the light went on. So I have enough light in here to get the LED running on this thing here. Okay, I will not necessarily say sitting inside here that I can get anything else running. So that's the reason why. Obviously, we have a lot of focus on that, but we also chose to have the cable one because there's a lot of micro USB options out there. And of course that allows you to have your charger in one position and your circuit in like another position. But what we many times do is that if we, for example, go out to school, we put a circuit in like that, and then we have our circuit and we can click it in like that, and then of course we have it just working out of that, and it can like stand by itself. The kid can run around in a hand and it doesn't swing around. So that is the PU, and we have right now the PU1 and PU2. Then I just want to show this circuit here again. So if I took this one here, one of the things that we also try to want to make sure of is that if I have a circuit like this circuit here, and I have a power chip, one of the things is that I can take, for example, in this case, I take a blank, I click it together, I put it together like I have here, so you can see, and now I have a very solid circuit. So when I plug it in, it of course doesn't move around. And the other thing is that I can, as usual, 3D print a box or whatever it is, and I can have it fitting in, and I don't have to worry about loose cables or anything like that. I can still put it into my box here, and I can have it running in this box here. So that's just to show an example of why we have the USB-A and not just the USB micro. We want to make sure that we could have something that was completely without any cables or wires, where the whole thing was a solid piece, so you can actually plug it into to the wall using, for example, one of these fellows here. Then let's look at the PPO1 or 4. So I have the PPO4 here. So you can see the PPO4 here, and just like in comparison, here is the PPO2, and the PPO2 take a coin cell battery. But size matters here. The PPO2 have way less energy than the PPO4. So the PPO4, the AA battery, and the reason why we focus on AA and not AA and other batteries is that currently the AA battery standard is the one that have the highest energy density of standardized batteries out there. So this thing here have a considerable higher battery density than any other battery, whether it's AA, AAA batteries or the coin cell batteries of any kind. So we have the PPO2 here because many times you have a circuit that uses so little power, so you don't want to carry around a block like this thing here. So the PPO4 here is the one that had advanced circuits. So there's components here that can tell you how the how much voltage there is on the batteries, because there's like a curve where how the batteries are falling slowly, and you can also measure the current so you have an idea about how fast it's going to go. In many cases, the provider of the battery, if you have like a couple of Energizer batteries or whatever, they will tell you, how many milliamp hours there's available. What we're busy with is that we're busy with a xChips that is like a little bit more advanced version of these ones here. So you'll be able to include inside your circuit what's called a column counter. and the column counter will run even if you put your circuit to sleep. It will constantly kind of like measure how much energy you use, and you can then on a later stage go in and ask your column counter, how much power do I have left? And it's a very, you can use it in design just to check, and you say, listen, is this good enough for my design here if I program it to be awake like for a few seconds every hour and so on. So you can use it both like in the design of your circuit, but you can also use it in your live circuit to kind of like give exactly feedback. So this circuit we have on a PPO4 here is an analog circuit giving voltage and current. The column counter is a digital circuit that gives you very much more accurate information about how much power you have used, and if you know your battery capacity, obviously how much you have left in your battery. And as I said, instead of using Duracell or Energizer here, you can use rechargeable batteries and plug them in instead. And then you have yourself a rechargeable station with a PPO4, PPO1 also. Then I want to demonstrate the PTO1. So the PTO1 is this fellow here. And a new version of this is coming out where this terminal that sits up here is actually meant to sit at the bottom. So we have like different standards that, when you click these things here together, it suddenly just makes sense. But this is kind of like an input because power comes into the circuit. So therefore, it should sit down there. And that's, of course, no different, for example, from a bridge where the power also comes from the bottom. So all our power circuits provide powers from the bottom. So this thing here was a reminiscence from when we did like ATC and other stuff where they had like the screw terminal on top where they're meant to be, but this thing here is meant to be on the bottom. We also experimenting with a mains power, so this is a circuit that can take 110 and 220 volts, but we haven't released that because mainly it's a little dangerous to play with that kind of power levels, and it's much better to use one of these that's approved in your country and have the right plug, and you can then use any of the PUs for power. The nice thing about this one is that there's no plus and minus on these pins here. So you can connect the one or the other side of the battery to this one here. The circuit itself will automatically reverse the polarity so it's correct for the circuit. So we made sure that you're not going to screw up anything by putting plus in on a minus in on a plus. Like if you were similar to putting a battery in the wrong way around. So with this thing here, you can put any kind of power between 6 volts and 24 volts. So, you have your garage door opener, or you have your car battery, or you have like an old 9-volt power supply, or, whatever you have out there of old power supplies and industrial power somewhere, you can put that in. And then you just have to feed the the 2 power pins into this thing here in any order. This one doesn't matter. And as we normally say, well, if you need any kind of tool, then a screwdriver should be kind of like the minimum thing you invest in. So this thing here is, you can screw your 2 wires in using this PTO1. Then we have our PL01 and a PL02 LiPo power xChips. So here I have the PL01, and here I have a PL02, and they look similar. You can see this, the PL02 is a little bit more occupied here by components, and that's because this one here can handle solar power input. So in this version here, the solar power is on that pin that sits here underneath this pin here. So that's not very useful for most people. So what we've done is at a new one, we've taken out, one of the connectors here, and we put a screw terminal in, similar to, the PDO1. So you actually can put your solar power in here. And it's just a normal solar panel. It's not like anything special. You just put it in there, and it provides power into the circuit, and the circuit will have the solar charging circuit. So it will charge a LiPo battery. So this looks like this thing here. This is a 1100 milliamp hour LiPo battery. 3.7 volts is the standard in the LiPo battery. So these ones here take 3.7 volts. I think they're called S1 or S2. I can't remember the number, but they have like a standard where 3.7 volts is a standard that we take on these PLO on both the PLO1 and PLO2. But on the PLO2 we also take solar power. So when we have the screw terminal and you have the LiPo battery, then you have a closed circuit where you don't have to use, for example, the micro USB for anything. But right now you can charge the battery, your LiPo battery, both with the solar and with the micro USB. On a PLO1 you can only charge your battery with the micro USB here. So when you can also look at a PLO1 as kind of like a battery backup. So you have it maybe powered by micro USB constantly, but if suddenly there's no power, then the LiPo battery will kick in and it'll feed the circuits. And as soon as power comes back, then it will feed the power into the rest of the circuit and will charge the LiPo battery. So this is a little combination of your uninterruptible power supply for your circuits. And then bridges and interfaces. And here is two component here. So I have this Dragon board, as I mentioned earlier, and here I have a micro USB, and I have done some videos earlier with all the other single board computers, but there's no big difference. So the whole idea is that we have a bridge here, and I'm also gonna provide a interface, because we have a programming interface somewhere on my desk. There we go. So here is a programming interface. So this is the IPO1. Now, this big chip that sits in the back provides a programming opportunity. So it takes USB, and then you can program a thing like the CW1 with this thing here. But it also provides power. So you can see this thing that sits on that side is exactly the same as the one you have on the front here of the PO1. So those both provide power. This one here also provides programming capabilities, and of course you can also use it to communicate with a serial port from your CW1. So it goes serial port from the CW1 into a computer, and you can then on your console see what's happening on the CW1. So we call that an interface because it actually have a program interface, because it have those as its main opportunities or the functionalities, but it can provide power as well as the PO1. So this is an interface. We have a number of different interfaces. So I'm just demonstrating the one here. We have a lot of bridges because we have bridges for all our single board computers. And on this one here, the single board computer here provides 5 volts. So we are converting that 5 volt to 3.3 volts. That's happening here. It also communicates between the single board computer and our components. So if we have, like, for example, a display that we want to connect here, that one 3.3 volts, and we want to signal to the display what I have to write. This board here use 1.8 volts to tell us to signal, and we need 3.3 volt because everything is 3.3 volt, both the signal power. So these chips here, they convert the 1.8 volt to 3.3 volts for the signal, and this convert 5 volt to 3.3 volt for the power. So all pins here are 3.3, and all the signal pins here 3.3 volts, and we have 3.3 volt on the power side here also. on a USB, sorry, on a Raspberry Pi. I'm just gonna drag in a Raspberry Pi I have here. So this Raspberry Pi here, I have a BIO1 sitting on this Raspberry Pi. There's a camera connected and it's running right now. But there's no components here like there was on this one here. And the reason for that is that the Raspberry Pi provides 3.3 volts directly, so we don't have to convert it. And it communicates 3.3 volt also, so we don't have to level shift that. So therefore, the bridge here, the only thing it does is that it just converts these pins that sit on the bottom to something we can click something into, and then we put a power LED onto that thing as well. So that's the way that that we use this, and you can see like here and on a bridge here that we have that coming from the bottom, similar to the IPO1 and also to the PO1. They all provide power from the bottom of the circuit, so therefore we want to make sure that they all do that. So that was a little gaffer here we had on a PTO1, which in the future will have that on the bottom. It works fine. It's just like one of the standards where we broke it a bit. And then the last thing before I end the thing here is USB-C. So on the CW3 we decided to put a USB-C in here, and of course the USB-C is for those who have like old computers and things like that, can be a little annoying, but you can get like converters like this thing here which you plug in, and then it's micro USB here. So you will have and a lot of providers of course have this thing here because there's a lot of old equipment out there. So getting these converters here shouldn't be the biggest problem. But new laptops are using USB-C. So therefore we have, the USB-C cable here. This is a cable that converts to a normal USB, and we can convert it back again to a to USB-C here. But we want to make sure that in the future that all our cores, all our devices, where we decide to put something on directly, is going to be USB-C, starting with the CW3.